I'm a principal solutions architect here at Eon, but more importantly, we have great guests or speakers to talk about DynamoDB and Keyspaces. I have a guest that you already know, at least one of the guests, but let me have them introduce themselves. Alex and Vikas, go ahead, please. Alex.
Yep, sure. So I'm Alex DeBrie. I'm an AWS Data Hero and author of the DynamoDB Book. So I've just done a bunch with DynamoDB over the last
Mm.
7 years now, consulting, talking, training, stuff like that. So yeah, just do a lot of Dynamo stuff in the community and excited to be talking on here today.
Vikas?
Okay. Yeah. Hi, everyone. I'm Vikas Panghal. I'm Senior Manager for DynamoDB and Keyspaces, both very highly scalable, available, durable, non-relational database services. I'm sure many of you would already be aware of these services. And I'm all here to share our thoughts about how these services are used and how can we help our customers and how we are looking forward to further support our customers in future. Yeah.
Wonderful. So what we're going to have today, we're going to talk about Dynamo and Keyspaces, when it makes sense to use each one of those. Obviously, we're going to talk about AI because in the past, the data and accessing the data was built for humans, and now it's changing. In that regards, there is a very important recent release of DynamoDB. I'm talking about the vector search, and Alex prepared an amazing demo that we will present later on. I believe this is like a live only, so great for everybody who has joined. You will be able to see the great demo of vector search. I played with it around earlier today. It's both interesting and funny. We're gonna talk about data protection, how to make sure the important data that you have, whether it's in Dynamo or Keyspaces or maybe other databases or resources, is well protected for different scenarios. So that's more or less what we're going to have today. We highly encourage everybody to send us questions. We hope to be able to answer as many questions as possible. And that's it. Okay, let's start the fun. And with that, let's maybe talk about Dynamo and Keyspaces, when to use each one. Both are obviously the AWS services. So Vikas, you are like the product overseeing these resources and others. Can you walk us through what is the rationale for an architect or a data engineer to use either one of those services?
Yep. So both DynamoDB and Keyspaces are non-relational serverless services. That means you don't need to provision any capacity as you build your databases. So you can literally get 0 to 1 in few minutes, if you will. Now, we do hear this from many of our customers, which service to use when. So if you are building a net new application, a greenfield workload, or if you have other applications in your quiver that are using AWS and you're looking for a cloud native ecosystem play there, my recommendation is to use Amazon DynamoDB. It is very well integrated with our AWS ecosystem. You can stitch things together. It is directly integrated with S3. We have integrations with Lambda, Kinesis data streams, and so many other AWS foundation services. And the best thing is, like, you don't need to even provision any capacity, and you get started in a few minutes. So any net new workload, you want to get faster time to value, just get started with DynamoDB. That's what my recommendation is. And if you have very high Apache Cassandra footprint, if you were using Cassandra workloads, whether you're self-managing those workloads or trying some other options, alternative options, but using Cassandra under the hood, you can get started with Keyspaces. Again, the beauty there is, like, you don't need to provision any servers. It is fully serverless, works on the same primitives that DynamoDB works. So it scales up, scales down automatically, and you would maintain your Cassandra schema, and you don't need to change your applications, and you can just get started bringing your workloads to Keyspaces and modernize all of your Cassandra workloads.
Yeah, and I think, when the architects make the relevant decisions on, in this example, which database to choose, Speaking of AWS, I believe it was Jeff Bezos who led the term of one-way doors and two-way doors, meaning two-way doors is something that you make a decision, you enter a door, and if you don't like that decision for whatever reason, it's pretty easy to go back. But there are also the one-way doors that once you enter the door, it's either impossible or very difficult, expensive, and taking a lot of time to find a way back through that door. So whenever you make a decision, besides making the decision, also think about whether it's a one-way door or a two-way door. And sounds like here it's closer to one-way door. There is going to be some hard work, relatively hard work to change. So take your time and make the best decision that makes sense to you. And with that, Alex, I'm sure you had so many DynamoDB users coming from so many different places. From your experience, what is like the mental shift that Cassandra or maybe other users and architects needed to do when they started using or getting familiar and more closely familiar with DynamoDB? What have you seen about what did you see about that?
Yeah, I'd say if you talk to Cassandra users, they're actually pretty good and pretty used to Dynamo and thinking about key-based access and thinking about your access patterns first and modeling that way. So like those are an easier shift to make. The harder ones are people that have come from a relational database world or even NoSQL like MongoDB, DocumentDB, where it has a lot more flexible access patterns. It has a query planner. Um, you just have a little more flexibility with evolving how you access that data over time. Whereas with Dynamo and Keyspaces, you want to do a little more thinking about like, hey, what's the main way I'm going to access this data? That's the important
Mhm.
part. I want to make sure I structure the rest of my item well so that it makes sense and things like that. But really, you're thinking, hey, how do I access that data? And really getting them to think access patterns first. That's like the big mindset shift that has to happen there.
Okay. And I think we're all talking, to other people trying to understand how they're going to use and access the the databases, the data. But as we are all seeing, it's not necessarily that those people will be the ones using the data, um, because in recent years, more and more AI workloads and agents are the ones that accessing the data. And because you see the different requirements, feature requests coming from everybody. What have you seen in the last year or two, and how AI is maybe shifting the roadmaps and um, the priorities of what AWS is building in that space?
Yeah, we have actually seen very interesting, shift in how AI is changing or evolving our databases. It's actually multidimensional shift. One is where customers say that we want to use database for an AI. And what they meant by that is they want to use the database for short-term memory or long-term memory for their sessions. And to do that, they also need to have they want to run some RAG workloads and and the other AI related workloads where they need vector search capabilities. So which is where we heard those customers and considered that use case being evolving more and more. And previously, DynamoDB had an option of zero ETL. We still have that to open search, and customers can store their core data on operational data on DynamoDB and store their vectors on OpenSearch into the vector search there. However, building that pipeline added operational complexity and latency as well. So having all of that natively on DynamoDB helps our customers, which is what the first core trend that we heard. So we built that, and many of our customers have started building solutions on top of that. The second is more of an AI within a database where they want to use AI capabilities to further, make the database autonomous, if you will, like, automatic patching, automatic partitioning, tuning of the databases, which we are under the hood doing to make sure that we offer the best experience to our customers. And in addition to that, like we're also seeing some sort of like the users who are using SQL or SQL-like dialect to interact with these databases, now they're using more and more natural language to interact with these databases, right? So we are thinking on that space as well, building the right MCP tools for our developers so that they can interact with DynamoDB without having, or even for Keyspaces as well. Like they don't need to know CQL or Cassandra query language, if you will. They can just interact with the database in a natural conversational way and get the meaningful insights. So these are some of the trends that we're getting. And another one that we have heard from our customers is like as they're building these agents to be interacting with these databases, these agents have very spiky workloads, and sometimes they want to do some experimentation. So, and they don't want to mess with their operational data that is running on DynamoDB or Keyspaces. So they're looking for better options of how they can smoothly do the experimentation without impacting the production data. So think of it like having different copies or versions or branches of the data so that their agents can do some experimentation, and if then everything is fine, they can push it back. So that's one space that we are further exploring with our customers. And that's the direction that generally we have seen more and more customers are getting into with the use of AI.
It's interesting that you mentioned those, let's call them the responsible users.
Yeah.
Think about, okay, how I'm going to do those spikes and workloads that might affect my production workload. So I need to think, 2 steps ahead and make sure that I don't do anything that will harm or risk my production workloads. And the reason I'm smiling is because I'm sure not everybody is that responsible, and funny thing, funny things can happen to production, especially from automation coming from AI. And we're going to talk about data protection if something happens to your data, but that's just one aspect. The other aspect is let's say unnecessary load that can impact the SLA, the service of those services. And funny that you also mentioned, natural language querying the data. I'm getting older, and in the past, I was interviewing engineers, and I had like 4 sections of what I'm asking engineers, things about networking and TCP/IP, things about compute and how things work in the cloud. And one section was about SQL syntax and do you know how to write an SQL query with the relevant joins and keys and things like that. So maybe today it's not that relevant because you don't have to be an SQL expert in order to access the data that you want. But beyond accessing the data, there is how you structure the data and how you make sure it's stored the right way. And Alex, what did you see recently with AI, not just accessing the data, but also gradually, adding more data to, let's say, DynamoDB in a way that is more automated and maybe, with less control from humans. So what eventually have you seen happening to those schemas of DynamoDB recently?
Yeah, I think like AI in the development has been a big help with Dynamo and with that process. I mean, like one thing I would say with Dynamo is, a lot of the database work that maybe happens within a MySQL or Postgres or something like that actually happens in your application now. Like you're more, if you do have relationships between items, you sort of have to like maintain some of that yourself. Or if you have certain constraints you want to maintain, you can't have constraints in the database like you could with a Postgres having a check constraint or something like that. So you have to more maintain that in your application code. And then also just evolving your schema over time and having to know, hey, if I pull like a V2 version of my schema, but now I'm on V4, how do I sort of, migrate that object from one to the other? And I think, these agents, they speak languages, they speak databases pretty well, and they're able to do a lot of that modeling work. They're able to help a lot with that, like invariant maintenance stuff, constraints and condition expressions, all those sorts of things that used to be tedious to write out and tedious to even maintain, to think about, if you can describe, the core objects in your application and what sort of constraints you want to maintain and things like that, have that somewhere. They do like a pretty good job of maintaining those things in your application code and taking that burden off of you and even checking for like hidden edge cases that you might have missed and things like that. So I think it's been a boon in that sense of just like a lot of that either boilerplate or just like stuff you had to do in Dynamo before that was kind of tricky is now it's still something you want to know about and review and think about carefully, but at least like the act of writing it out and thinking about all those aspects, the bar's gotten a lot lower, which is nice.
Awesome. I see some questions from the audience. First of all, thank you for everybody that is writing. Several questions about the vector search. And before we address maybe the questions directly, I want to make sure everybody is aware of the release from a few weeks ago by AWS. And because I want to ask you, before we talk about the new release and how people and agents can use DynamoDB differently or in a better way now, let's say I wanted to use vector search a month ago, 2 months ago. How would I be able to do that, and how is it done today? Like what has changed, please?
Yep. So before the vector search feature that we just launched earlier this month, customers used to store their core operational data in DynamoDB and their vector embeddings in OpenSearch. And we had a feature, we already have it even now, is zero ETL to OpenSearch. And so customers had to build that pipeline. We tried to simplify that pipeline from DynamoDB directly integrating it to OpenSearch. And it uses our CDC-based approach, like CDC streams. As and when you write anything to DynamoDB, it streams it to OpenSearch. But managing that pipeline was a pain for many of our customers. And they said that this is not something that their workloads also need in terms of like, if they're writing something, DynamoDB is very good at very fast reads. And now, because the data is going from one place to another and they have to do the search in OpenSearch, there's a latency between the two services. And so that was a huge barrier for many of our customers, data freshness, if you will, or latency, and operational overhead of maintaining these pipelines. Now, putting all of that data in a single location, like we have co-located everything. Like you have your metadata, you have attributes, you have vector in one single database, and you can just make one call and you get everything. So nothing changes from your access patterns. It's just that now everything is sitting in a single location. And the best thing is like you still get a single digit milliseconds even with the vector search, we have like 99+% recall and a single digit millisecond latency. So that's the complete paradigm shift that customers are going through now with this feature.
This is amazing. There are other external vector-based data stores, databases that were built explicitly to address those challenges. And honestly, now with those capabilities being built in together with your operational data, my personal opinion is that you need a really, really, really good reason not to use something like DynamoDB with the built-in capabilities. If you build your own search engine, or if you build like very configurable vector searches that you need some edge cases, maybe you should look elsewhere. But probably for the vast majority of your use cases, now there is a new thing that totally changes, the rationale of how you make those architectural decisions. So pay close attention to what AWS released with DynamoDB and vector search, and obviously later on, as promised, Alex will show end-to-end how it works in his environment. And maybe before we start talking about other things, I see some great questions from the audience. Let me pick one specific from Jonathan, that is asking about how we compare the new capabilities of Dynamo vector search with other providers. And he mentioned specifically the Postgres and vector plugin. Alex or Vikas, do you want to address that question, how the DynamoDB vector is compared with other AI vector providers, such as the Postgres vector plugin?
Yeah, I can take like a first cut, and Vikas can correct me, I'm sure, in a lot of different areas as well. But I mean, I think one thing, whenever you're looking at, hey, Postgres has this sort of add-on, whether it's full text search or vector search or just different things like that, you have to think like, hey, all like that's your operational data, and there's just like it's all on one box usually if you're running Postgres, and sort of there's just like resource contention around all that sort of stuff. So especially vector search in particular, I believe PJ Vector uses the what is it, HNSW index for most of it, right? This which is like a very it's kind of a big index, right? And it really works best if you can hold it all in memory, right? So if you have like a pretty big data set with all of them having vectors and stuff like that, you can build this index with PG Vector and query it. If it fits in memory, that's going to be great. But also, your database probably needs its memory for its regular OLTP operations that it's doing and different things like that. Or if your data set just gets too big and now it's not all fitting in memory and now it's paging back and forth from disk a ton, you're just going to see like some pretty significant performance differences there. So I think like with Dynamo, one thing that's nice, and this is just like the Dynamo way, is just like, everything is like more segregated, and it's like it's not going to let you like bomb yourself with like some bad access patterns over here that's going to affect everything else, right? So your vector indexes are going to be separate from your main table, going to be separate from your other secondary indexes. Any queries you do against that vector index are not going to impact the rest of your workloads and things like that. Also, just like more of that like fully serverless experience that you get with Dynamo. So like you're charged based on the storage you put in there and the queries you run against it, but it really does scale to whatever you're going to put in there. I do think like the vector queries on Dynamo it isn't like at any size, it's not going to have the same like small performance envelope that Dynamo has, depending on like how specific your query is and how long tail it is and how big that data set is. But it still does give you like a more bounded performance envelope than you might see with other databases. So I think those are like the big things with Dynamo. Hey, if you want that fully managed experience, you don't want to like have contention across your other workloads and really handle it at any scale. I think those are going to be the big upsides of Dynamo's version.
I totally plus one to that, what Alex, you said. Yep, it's fully managed experience, right? Like you still get all the primitives and foundational capabilities of DynamoDB, like fully managed, serverless, and you don't need to think about even your index tuning as well, right? Like I know you talked about like one of the index types that Postgres PG Vector supports, like HNSW. I think they have like IVF flat also or something. For DynamoDB, you don't even need to get any of those selection paradox, if you will. It is fully managed, and you don't need to do any tuning, if you will. And the core foundational pillars of DynamoDB are applicable for even vector search as well, with the same read latency, durability, and availability. Yeah.
Yeah, let's maybe take a step back. I see a question here from Stuart that is asking, can you please explain what a vector search actually is? Okay, so let's make sure everybody's on the same page and we have a clear answer to that. Let me start, and I'm sure Alex and Vikas, you can enhance my answer. The regular search is that you have those records in your database and you search according to specific things that the search can find. A vector search is more, I may call it heuristic kind of search that is more built for natural language. I'm not talking about the implementation and the embedding and how it works. I'm more talking about the way that you want to access and search the relevant data. Let's say you have different records that talk about different things. Let's say a chatbot that can help you, get the right answers to your questions. And maybe one of those questions will be around how you reset the password. Okay, so maybe the answer in the database will be, how do I reset the password? Here is how you reset the password. But what if the user asks, my account is locked, what should I do? Okay, so how do you make that heuristic that what that user is really looking for is a reset password kind of workflow? So this is my way of explaining what vector search is, compared to a static, exact, specific search. Do you tend to agree to my analogy here, Alex and Vikas?
Yeah, I think that's good. Yeah, exactly. Regular search, like maybe you're searching off a title, a description, maybe like some tags, but they're like all explicit stuff that this data has already sort of been tagged with in some certain way. And whereas now with vector search, more semantic search, it's like, hey, what you're going to do is take whatever content you have, you'll turn it into a vector, which is just going to be like an array of decimals, right? And that sort of indicates like where it lives in like this vector space. It's hard for me to imagine roughly like what that all looks like unless you're really good at math. But it's like going to place it somewhere in space in like a very multi-dimensional place. And now if you go do a query, you turn that into a vector and that's going to be in some space. And you're like, hey, what are the closest things around this that probably has some semantic meaning for it? So like, yeah, again, if you're talking to your chatbot about a lot of different things, if you're talking about sometimes about security, sometimes about your finances, sometimes about like, hey, where you want to go visit when you go to France later this month or something like that, you have all these different things. And then when you're talking, you have like a semi-related security question or something like that, it could maybe go find those security-related things that you've already discussed and load that as context or something like that. So without you explicitly tagging it that way or having something else tag it that way, it's just like, hey, these generally like mean or are similar to the same to what we're talking about now.
Yeah, yeah.
Because you
I think there is like semantic search is very common, Alex and Ohad, like which we have heard from many of our customers where vector search is used. There are so many other use cases also where vector search or similarity search, if you will, is very helpful. Like think of it like you're building a recommendation system engine, right? So if a user has bought something, then you as a provider, you might want to give some similar items to them, like, hey, you want to recommend them that if a user has bought X, then can they buy something else as well, which is similar or could be related. That's where vector search is also very useful. And more like with these LLMs, right? Like customers are building their RAG applications, right? So they want to like pass the LLM to their specific corporate data and then make the right inference. So that is where also like we use vector search. They distribute the entire corpus of their data to certain vectors and then find the relevant information rather than just hallucinating.
Okay, I hope that answered the question of what vector search is. And we're gonna have a detailed demo in I think about 10 minutes of Alex demonstrating the capabilities of DynamoDB vector search. But before we do that, let's talk about data protection. And disclaimer here at Eon, we focus on making sure that your data is being protected well. Now, let's say your data is in DynamoDB or in Keyspaces, or honestly in other places, but let's focus on those resources for today. You should think about the risks coming from mainly two types of entities. One is us humans, doing the wrong thing, writing a bug in the code or changing something in a wrong way. But more and more, the actual workloads are AI workloads, and something can affect your resources. So it's important to have some strategy around data protection. And DynamoDB is used in so many places for production data. It comes with its own built-in point-in-time recovery (PITR) capabilities that can help you in so many cases. Let's start with that, maybe. Vikas, can you walk us through what is PITR for DynamoDB, and when do you see your customers using that to protect their data?
Yeah, so PITR is nothing but point-in-time recovery, and think of it like a continuous backup of your data. And we highly encourage our customers to enable that for their production workloads because if at midnight, 2 a.m., if your agent deletes 50,000 rows, you don't want to scramble next day what happened. And so if you have a backup enabled, you can recover it very easily. So that's what the core essence of this feature is. Like you keep a continuous backup and restore it at any point in time. feature is available for both Keyspaces and DynamoDB. And as of today, it supports up to the last 35 days of restore. So you can restore up to 35 days. And while that solves some, vast majority of our customers' concerns, however, as we are learning more and more from our customers, they need to have more capabilities on this restore capability, specifically like having longer duration of data for their compliance or regulated industries. Think of it like, financial or healthcare industry. They need to store the data or they should have the ability to restore the data beyond 35 days. That's one of those, right? So, and then also they want to do some like analysis on the data that is stored as a backup, like in place analysis on the backup data itself. So that's where we have we're partnering with Eon, helping us to complement our backup solution, where customers can actually restore their data beyond 35 days. They could do in place Athena based analysis on the backup that they have done, and probably Ohad can speak more on that. But yeah, these like backup is definitely one of the core capabilities. As agents are, or even human beings are using these production workloads, we need to make sure that we have a good mechanism for trust and control. So for trust, we already have good IAM policies, resource-based access controls for both of the services and whatnot, VPC endpoints, private links, everything. But on the control side is where the backup comes, and that is where we highly encourage our customers to enable these things, and where possible, extend their retention of their backups as well.
Absolutely. And in a minute, I will say a few things about strategy for data protection and what you should think of, as an admin or as an architect of your system, what kind of risks you need to be aware of and protect. And it's also important to mention that extra copies is nice and important, but it's not necessarily going to protect you from the relevant incidents that you need to be protected against. And Alex, you have talked with a lot of DynamoDB users over the time. What have you seen that you want to, if you have one thing to tell to DynamoDB users when it comes to data protection, one tip, one thing we can learn from you, from your experience, what would it be?
I think probably like sort of like knowing your access patterns. It's really like knowing your needs and like what sort of data recovery requirements you have and different things and understanding like, hey, are the normal backups enough? Is PITR enough? Do I need something more like an Eon that has some different features and things like that? Do I need cross-region stuff? Do I need, do I need global tables? Because like, hey, if a region goes down, I need to be sort of active somewhere else. So I think really just like truly thinking about your needs and what would happen if in some of these disaster scenarios and making sure then given those needs, you're matching whatever solution you do pick to those needs and things like that.
Absolutely. So let me say a few things that I want our listeners to think about when it comes to data protection. Alex mentioned the kind of region failure and what happens if a region fails for a short amount of time, or God forbid for more than that. So how do you protect against that? The default 35 days of PITR versus longer retention. Sometimes you actually need it for operational needs, and sometimes you have to be able to demonstrate that you can recover from longer than that for compliance needs. So are you aware of your compliance needs, and are they aligned with what you protect? We still didn't mention ransomware. Okay, so somebody hacks into your production environment and starts encrypting the data, and maybe also looks for the extra copies of the data. So think about immutability, think about logically air-gapped, keeping the extra copies, the snapshots is something that is both immutable and logically air-gapped to ensure that nothing can delete or encrypt both the operational data and the snapshot. Think about RPO, RPO and RTO, how much time it takes to protect the data, because when you need to recover, when is the basically relevant snapshot with PITR, it's obviously amazing. But if you have different requirements and other things, so think about RPO. And RTO, the time it takes to recover the relevant data. And here, think about two scenarios. Think about when you need to recover the entire table, the entire database, okay, if something really bad happened. But very often, you just need to recover a specific record, a specific table. And if you have a solution that can do that very quickly, it means that the RTO for the vast majority of the incidents reduces dramatically. So these are the things that we're seeing at Eon that our customers care about, and they want to have a strategy that aligns with all of those different scenarios. Vikas or Alex, do you have anything to add about what I tried to share here? No.
For me, I think you covered it pretty well. Yeah.
You were spot on that. Yeah.
Plus one.
Yes, exactly. Agreed.
Okay. Before we go to the live only segment, do you have like one thing that you want to tell our users? Alex, you kind of said that already, but maybe Vikas, if you had the chance to talk with DynamoDB or Keyspaces users, and you want them to learn one thing today or think about one additional thing that you want to put in their minds, what would it be?
Yeah, so I would say getting started with these services is very easy. One thing that I would suggest all our customers is spend some time on their access patterns. Think about the access patterns, because that is what would make their journey more seamless and would not let them into eventually, into challenging situations where they may realize like they should have re-architected their system, or they should have had a different access pattern. DynamoDB is very good at very fast reads, and customers try to maintain high cardinality of their partition keys, and that's what we suggest to our customers. So that's one thing that I would say, like focus and get your access patterns like stabilized, or think deeper about that, and then we have both of these services that can help you.
One last funny question, or not funny, but I think it's a very nice question to you, Alex. Has DynamoDB changed sufficiently in the recent years that you've considered releasing a new version of the DynamoDB book?
Yes, I would really like to. It's so much work. It was such like a labor of love the first time. I seriously quit my job and worked on it straight for like 4 months.
Wow.
But I think there has been a lot of stuff that's changed. I was talking with you all last week about just like I think a lot of the improvements Dynamo has made over the last couple of years has changed in some ways how you model it. Thinking about adaptive capacity and the on-demand billing, the multi-attribute secondary indexes that they released last year, just like a huge one in a lot of different ways. And now vector indexes, like there are a lot of big things that have changed, and I think make it a little less necessary to use like single table design. You can have more like separate dedicated tables, which just simplifies modeling in a lot of different ways as well. So I would love to. I don't know if I can find the time for it anymore, but it'd be, I don't know, TBD.
Good. Okay, I think we're about to finish. I want to thank you deeply, Vikas and Alex, and thanks everybody for joining. Please follow up if you have any more questions. I want to say about Eon, we help you to protect the data. So if this is relevant to you all, please feel free to reach out or to me personally, or request a demo. And I hope to see you all in our next episode of Cloud Cuts. It's going to be on September 9th with Victor Farsik, the host of DevOps and AI Toolkit and developer advocate at Outbound. We'll be chatting about my agents build while I sleep. Here is the part nobody talks about. So if your agents build while you are asleep and they do some funny things, let's talk about it in the next episode. Thank you, everybody. Have a great rest of the day and see you next time.
Thank you.
Thank you.